So, in the previous video, we have computed the radius of convergence of this function given by the power series. Now, we have to compute the radius of convergence of the derivative of this function. Now, notice that the function expression is not given to us, right? So, we don't know what the function is. We just know its power series representation. So, in order to compute the derivative, we have to compute the derivative of the series, right? And that will give us a new power series, and we have to find the radius of convergence of that new one. Now, how do we take the derivative of this new power series, of this particular power series, right? Well, what is a series? It's just a sum of various terms, infinitely many of them. So think about how do you compute derivative of a sum of two functions. You just take the derivative of each function separately and then add them together. So we do the same thing here. There are infinitely many terms, yes, but we take the derivative of each term separately. It's called the term by term differentiation, and then add them all together. So what I mean is, when you're computing ddx of this entire series, x to the n over 3 to the n, is nothing but switching the summation notation with the ddx notation, because you have to take the derivative of each of these terms, term by term, and then add them. So it is going to be a series from n equals 0 to infinity, and then derivative of x to the n over 3 to the n. Okay, and then let's see what the derivative is. Now this is where you have to be very, very careful, okay? Look, we are taking derivative with respect to x. X is the variable now, not n. N is just a constant, okay? So 1 over 3 to the n is a constant. So you keep that as it is and only take the derivative of the x component, the x term, and it is x to the n. And what is the derivative of x to the n? Using power rule, it's just n x to the n minus 1. So that is the new power series, which is representing the derivative of this original function. All right? Also notice that the center for this series is still 0. Center doesn't change. So this is the new series. Okay, now we have to compute the radius of convergence of this new series. And we use ratio test one more time. So ratio test again. Okay, now an is this new expression, n x to the n minus 1 over 3 to the n. And so an plus 1, remember, you just write down n plus 1 wherever there is n. So this first n becomes n plus 1. Then in the exponent of x, you have n plus 1 minus 1, n plus 1 minus 1, and then 3 to the n plus 1. And n plus 1 minus 1 is just n. So you can simplify this as n plus 1 x to the n over 3 to the n plus 1. Okay. Now let's form the ratio and take the limit. So it will be limit n approaching to infinity. Remember absolute value of the ratio an plus 1 over an. As usual, the n plus 1th term, write it down as it is. So n plus 1 x to the n over 3 to the n plus 1. And then an is in the denominator, and you flip it. So 3 to the n over n x to the n minus 1. Okay. And now let's see if we can cancel anything. Look, the 3's will cancel. So let's write it down one more time. So there is an extra 3 in the denominator. So we'll have that. Now n plus 1 over n, nothing will cancel there yet. And look, the x to the n and x to the n minus 1, they are like terms and they will cancel. And how many more do we have? So denominator we have n minus 1 many. Numerator we have n many. So there's 1 extra in the numerator. And then we are left with n plus 1 over n. Okay. So absolute value should only be applied to x because x can have negative values, but everything else, the 3 and n's, they're all positive. So we have limit absolute x over 3 n plus 1 over n. And notice that this is a limit on n, so absolute x over 3 is just a constant and you can pull it outside. So you have absolute x over 3 and you take the limit on just the n plus 1 over n, and now I'm rewriting this expression because you can divide both these terms by n. So you have n over n, which is 1, plus 1 over n. And you know that as n goes to infinity, 1 over n will go to 0, right? This will approach to 0. So your limit will turn out to be absolute x over 3 times 1, which is absolute x over 3. And recall, this is ratio test. Series will converge if the limit is less than 1. That will imply convergence. And absolute x less than 3, how do you solve that? And we have solved it before, right? Do you remember in the previous video? Is absolute x less than 3, and that means x lies between negative 3 and 3. And so this is your interval of convergence. So if you draw the number line, center for this new series is still 0, and the interval is negative 3 to 3. So radius is 3 as before. So the radius of convergence of this new function, which is the derivative of the previous one, is also 3. Okay, so in the next video, we'll compute the second derivative and then its radius of convergence.